Okay, we're going to have a look at a dry docking calculation now. I think at this point, just want to mention it's so important that you have a clear understanding of the formulas that you're going to use whenever you're solving stability problems. And it's so important that once you realise which ones they are, write them down. So I encounter here a dry docking problem. So I'm going to go to my table, my stability formula sheet, and I'm going to identify the formulas that I'm going to need to use. Well, the P force is trim times MCTC over LCF. I know I'm going to need that formula, and I'm going to need loss of GM is P times Km over displacement. There is this one using kg, but I always use this formula here. So I know straight away I'm going to use those two formulas there. I'll also use the true mean draft formula to get my displacement, but that's a fairly standard longitudinal situation. So the important dry docking formulas, P equals trim times MCTC over LCF, and loss of GM is P times Km transverse over displacement. So we're told our drafts, we're in salt water, and we're asked to calculate the maximum trim at which the vessel can enter dry dock so as to maintain a GM of 0.16 at the critical instant. Well, the critical instant occurs just before the vessel touches down forward on the blocks. So it touches down aft first on its stern, and then because it's trimmed by the stern, and then this, as the trim gets less and less, there's what we call a P force developing, which increases and increases, and it's at its maximum at the critical instant just before you touch down forward. And what we're saying, we only want to have a GM of at least 0.15 at that instant. All these problems, you always have to assume the Km is constant. So if we assume the Km is constant, it means that with our initial drafts, we can find the Km of the vessel. Okay, we've got the kg, so we can also find the GM of the vessel, with the Km being constant. The kg doesn't change because, of course, the displacement's remaining the same. So once we've got the Km and the kg, we've got our GM. We know that our GM has to be at least 0.15, so therefore if we can compare that to our GM that we've calculated, the difference between the two must be the loss of GM. Okay, so if we look at the formula, the loss of GM, we can work that out. We know the Km because that's constant. The displacement, of course, we can get because we can get our true mean draft. That means that at this particular juncture, at this critical instant, we can work out the total P force. And that's in tons, of course. Then we'll look at the next formula. We know the P force. MCTC and LCF we can get from the tables. Therefore, what we're looking for is the trim at that point to keep the GM at least 0.15. So here we go, let's have a look. We've got our average mean draft, get the LCF, and then get our true mean draft, 4.794. At 4.794, go in the tables and get these four values. You're going to need all four. Displacement, Km, LCF, MCTC. As we said earlier on, Km is constant, 9.14. kg isn't going to change, 8.74, so the initial GM is going to be 0.4. We have to have a minimum of 0.15, therefore the loss of GM, virtual loss or loss of GM, is going to be 0.25. When we put them into the formula, transpose the formula, because we know virtual loss of GM, we know displacement, we know Km, we find that P force, the maximum P force, is going to be 263 tons. Then we can put that into the formula here to work out the total trim. We know the P force, we know MCTC, we know LCF, therefore the trim, and it will come out in centimetres. And don't forget, that's also important, you must realise that the trim will come out in centimetres. So the maximum trim is 116.2 centimetres, or 1.162 by the stern. It doesn't matter which way you write that answer, you won't lose marks whichever way you write it. Then the second part says, okay, well, how much ballast do we need to transfer from aft to forepeak in order to reduce the trim to the maximum allowable? Well, we know that trim is weight times distance over MCTC. Okay, weight times distance over MCTC, or change of trim is trimming moment over MCTC, weight times distance. Well, we want the weight of ballast to transfer. The distance is going to be the distance between the two tanks, forepeak and afterpeak. When we go into the into the stability tables, we can get our LCG of the forepeak, LCG of the afterpeak from the tables, subtract one from the other, and we get the distance between the two. So we know our distance between the two tanks. We're looking for the weight transfer. We know our MCTC because we're transferring the weight, the vessel's displacement isn't changing, therefore the MCTC that we've calculated in the first part we can use in the second part. We also know the trim value because we know what our original trim is, which is between 4 and 5.6. So we know our original trim is 1.6. We know the maximum trim we're allowed is 1.162. Therefore our change of trim has got to be 0.438 or 43.8 centimetres by the head. So we're having to transfer the weight to create a change of 43.8. So we know our change of trim. Now don't forget, it's important that you write that in as 43.8 and not 0.438. You must write the change of trim in centimetres. So we know the change of trim, we know the MCTC, we know the distance or the shift, therefore put everything into the formula and we can find that the amount of weight we would have to move is 53.9 tonnes, 53.9. So just to re-emphasise, understand clearly which formulas that you have to use. Even if you've sort of forgotten a bit how you do these problems, write the formulas down and then start looking at the information that you can feed into the formulas, and that should help you to solve the problem.